In previous class, we run like Gaussian distribution, or we run standard normal distribution. We run like log normal distribution, and like some covariance and correlation coefficient, and like Spearman correlation or Pearson correlation coefficient. Learn all the things in the previous class. In today class, we will be going to learn like uh, inferential statistics. I will tell you first. Today class will run inferential statistics. Inside the inferential statistics, we will run first what is p-value. Number two, we will run like hypothesis testing. Number three, we will run like confidence interval. Number four, we will run point estimator. Nothing what it is mean actually. We will run. Number five, we will run like Z test, T test. Today class we will cover all the things: p-value, hypothesis testing, confidence interval, point estimator, and Z test, T test. Maybe in the next class we will cover all the things in the like statistics. We will cover all the things in the next class, and in today class we will just cover this thing: p-value, hypothesis testing, confidence interval, point estimator, Z test, and T test. Let me start from p-value. P-value is nothing but like data. Actually, p is defined as the probability value. That means p-value is nothing but it is probability value. I will give you a very good example. Let's say this is your space bar in the laptop. Let's say this is the space bar in the laptop. Then when you are going to enter in the space bar, there are more chances that you are entering in this position. In this position we are going to enter the space bar. There are very less chances that you will enter like this, from this, or here. There are less chances you may put like this. Let's say there is a space bar. There is very less chances you will press this space bar in the left corner or in the right corner. The most of the time you will put this space like here. Then if I will going to construct a like normal distribution, my normal distribution will look like this. That means a very chances that my space bar when I am going to hit, that is nothing but in the middle position, and very less time I am going to hit the space bar in the left position. That means let's say this is nothing but let's say p-value is 0.8. That means we are going to consider 80% of time in the space in the middle of the space bar. Then let me give you an example. Like p-value is nothing but probability value. And after that we will run like I will teach you one more thing, like hypothesis testing. Hypothesis testing is nothing but let me clear one more thing. Hypothesis testing, like one more thing is that in this distribution it is like symmetrical divided, and this is nothing but our mean, and this is 0.5%, and this is 0.5%. That means it is symmetrically divided to each value. That means hypothesis testing. In hypothesis testing, and let's say I will tell you one thing, that I will toss a coin 100 times. That means what is the probability of head? That is nothing but half. Probability of tail is nothing but half. As I am tossing the coin in 100 times, that means probability value of head is nothing but 50. Probability of tail is nothing but 50. It is derived from formula. That means if I am constrained to draw a distribution, then my distribution will look like this. Let's say this is my distribution, and this is nothing but my mean value. Let's say this is 50. If it is 50, let's say this is 55, 60, let's say 70, let's say 80, let's say this is 90, and this is, let's say, 100, and then in this side, let's say this is 40, 30, 20, 10, or 0 here. I will tell you in this case, let's say, or as per the experiment, we will get the value like 60. This is derived from the theory or formula. We will derive that 50 times head will come. When we like to do the experiment and we toss the coin 100 times, then in that time we will get the probability of head is equal to 60 times. That means we are getting 60 times as head. In that case, what we do is it's nothing like, let me, in this case what we are doing like if this is our mean, this is mean, our mean is nothing but 50, and our value is coming like this. That means in hypothesis testing, we will when if I am telling you that let's say 95% confidence interval is accepted. One more thing is what is confidence interval. I will tell you what is confidence interval. That means if our value will follow in 95% of this area, then we are going to accept the thing is that our coin is here. That means let me give you the clear. The thing is that let's say our in the hypothesis testing, always we have two conditions. First condition is H0 and second condition is nothing but H1. In H0, that is nothing but a null hypothesis, and H1 is nothing but alternative hypothesis. Alternative hypothesis. Our null hypothesis is like always the basic condition. That means the coin is fair. Fair means 50 times head and 50 times tail. That means our coin is nothing like if you put a coin, then there may be more than 50% chances to get the head or get the tail. That means if let's say if you are rolling a dice to get a 6 is nothing but the probability of getting a 6 is nothing but 1 by 6. But if we construct the dice in such a way that in two faces we are put the 6, a 6 value is putting in the two faces, then in that case that dice is not fair, that is unfair. Similarly, where our H0 is nothing but a null hypothesis, our null hypothesis is the coin is fair. Alternative hypothesis, our coin is not fair. Let me complete, then you will understand everything. The coin is not fair. I will tell one more thing is that your confidence interval is nothing but, I will tell you what is confidence interval. Confidence interval is nothing but 95%. That means if confidence interval is 95%, let's say this is a value and this is nothing but 0.025%. This is a value, let's say this is nothing but 0.025%. That means this underlined value is nothing but it is 95%. If our value, when we conduct the experiment, if our value will fall inside this 95%, then we will accept the null hypothesis. Otherwise, we will reject the null hypothesis. Let's say we conduct the experiment and we got the head 60 times. That means our head is our 60 is nothing but it is here, and the null hypothesis, that means the 60 is nothing but it is fall inside this 95%. Then we are going to accept the null hypothesis. I will clear one more thing is that if let's say probability of head is nothing, we got at 98. In that case, how it is 0.025? I will tell you that that means 95% is confidence interval. That means our significance value is nothing but, this is nothing but significance value. I will teach you one and one. Significance value. Significance value is nothing but 100 minus 95%. Then it is 5%. Then 5% is also divided into two sides. That means 5% is 5%. The left side is also combined with the left side, and both are totally 5%. That means 0.025%. That means this 0.025% is nothing but 0.025% which is here. Let's say this one, and 0.025 is following this one. If our conducted value, if let's say our probability of head we get at 98, that means the 98 is falling like here, probability of which here, then we can reject our null hypothesis. So we can say that the coin is not fair. We reject the null hypothesis, that means we accept the alternative hypothesis. That means we can say that the coin is not fair. That means in hypothesis testing, the confidence interval is given to you. Let me write one thing, that what is confidence interval. Confidence interval like it is defined as significance value. Here significance value will be given. One more point is that if our experiment value falls in significance value, then what I will do? Then I reject the null hypothesis. I reject the null hypothesis and accept the alternative hypothesis. Then you can say me that where the significance value, who is given to the significance value, or the domain expert give to the significance value. Significance value is nothing but it is represented by alpha. Let's say in the previous example I told you that the significance value is 5%. Let's say in this problem I will give you one more problem. Here the significance value is 20%. Let's say. Then how can we construct the graph? If significance is 20%, then our confidence interval is nothing but 100 minus 20%, nothing but 80%. The 80% is also divided into left and right. That means we can divide it, this is 40%. Then 40% data towards right. From mean, 40% data towards right and 40% data towards left. Let's say we'll toss a coin for 100 times and we get the head edge. Let's say we get a head edge 70 times we get the head. When we construct the distribution, it will look like this, and if this is our mean 50, let's say this is nothing but 70, this is 80, this is 90, this is 10, 90, and this is 100, and this is nothing but 40, this, let's say 30, 20, 10 and 0. In this case I give you that confidence interval is nothing but 80%. That means our significance value is 20% and confidence interval is 80%. Confidence interval is 80% and it also combined with left and right. That means 40% data towards left and 40% data towards right. If this is our mean, then 40% data towards right, that means this with this value, and 40% value towards left, that means this value. This totally graph is nothing but this is 80%. This is nothing but this is 80%, and this value is nothing but 10% in the right side. As our significance value is 20%, then 10% value in the right side and 10% value in the left side. Here I can say that our probability of head, what we got from the experiment, that is 70. That means our 70 is falling here. Then we can, as it is falling inside the like confidence interval, we can accept the here what we do. If our experimental value falls in significance value, then I reject the null hypothesis. In this case, our experiment value is falling inside the confidence interval. That means I accept the null hypothesis. If let's say I will conduct the experiment, I got the probability of it is nothing but let's say 9. Where is 9? 9 is falling. 9 is falling from here. This is outside the confidence interval. That means inside the significance value. Significance value. That in that case, what I will do? In that case, I reject the null hypothesis. This is nothing but all the concept in confidence interval, all the concept in significance value, and all the things. We will do some problem. We will get to know. If you ask me, then what is the actually use of the confidence interval and why we are going to use this confidence interval and all the things in significance value? Then I will tell you one thing that let's say we are not supposed to go to the, let's say I will calculate the height of the in our country, all the people live in our country. I am not going to 130 crore people. I will ask one by one, then what is your height and what is your height. And what I will do, I will just collect some sample, and from that sample I am going to derive the uh, uh, average height of the height of people in India. In that case, as I am not going to each and every person, then what I will get? Then maybe chances, maybe chances, there may be chances. What average I got, that may be wrong. That means the average I got from the, I am not supposed to go to the all people. Then what I will do, I just collect some sample and just considering that sample and study on that sample, I just find out the average value of the people in India, average height of the people in India. There may be chances, as I am not going to each and every person, there may be a chances that I can, which value I got from my sample, there may be a chances I got the wrong value. Then in that case, what our expert is to write that, let's say we got the sample, we can take the confidence interval as, so let's say 80%. That means in that value, let's say this is our, let's say this is our distribution. That means we can consider it, let's say our confidence interval is nothing but 70%. That means 15 to 85. If our value fall inside this, that means let's say we got the average height of the people, let's say 5 foot 6 inch, then we can derive that inside the, if we put the value from here, we can find a value like this 5 foot 4 inch. Here this is your upper limit and this is your higher limit, sorry, this is your lower limit and this is your upper limit, that 5 foot 8 inch. I will tell you, explain all the things when we will do some problem, you will get to know. That means if our value is fall inside this, then we can tell that which value I got from the sample, that is nothing but that is correct. If our value is if our sample value, or if you go to correct some sample, if that value is falling beside below from this lower end and up very much away from the upper end, then we can tell that our null hypothesis is not correct. That means we can choose the alternative hypothesis. In this case, what we run, we just run the p-value and the hypothesis testing and the confidence interval. After that, I will give you one more example. After that, I will tell you that if you have any doubt, you can tell me. Let's say there is an example. Before that, I will tell you one more thing, is that in inferential statistics, we deal with the sample data and we will assume the population data. This is the important point. Cannot out this out. That means in this value we just deal with the sample data and we'll assume the population data, which I told you that we just collect the sample data and do some operation, and we can assume in the top of that we can assume our what should be the average and what should be the value of in our population. Let's take, I will give you an example, and let's say I will tell you that there is a question. I will tell you that person has committed a crime. The person has committed a crime. That means a person maybe do some sort of crime or may not be. Then what is the chances and how can we relate our statistics inside that? Let's say in a null hypothesis, every cases in the hypothesis testing we are always consider a null hypothesis and always consider a alternative hypothesis. In this case, null hypothesis is nothing but he is innocent. He is innocent. There may be wrong in spelling. He is innocent. In the law, you know, the person is innocent until he is proven guilty. That means he is innocent. That means it is nothing but it is H0. And the alternative hypothesis, what is? Alternative hypothesis is not innocent. It is nothing but H0. Let's say after that we have to do we conduct the experiment. Conduct the experiment. What is our experiment? Experiment is like collecting evidences. Like you may collect the fingerprint, you may collect like DNA or some application maybe if you found, we will collect. After that let's say this confidence interval or this alpha value. Who decide this alpha value? In this case, alpha value is decided by the judge. Decided by the judge. Let's say alpha value is 70%. That means if our experiment value falls within alpha significance value, we accept the null hypothesis. Sorry, in this case what we will do, we reject. If your experiment value falls within alpha significance value, what we will do, just we reject the null hypothesis, otherwise I will accept. This is fixed. After that what I do, let's say this is my distribution. Our distribution, let's say this is our distribution, this is nothing but this is our mean. Alpha value is 70%. This is significance value. That means confidence interval is nothing but 30%. And 30% is also from 15% to right and 15% to left. 15%. That means if this is mean, this is, let's say this is mean, let's say 100, this is 50. Let's say this is nothing but 35, and this is nothing but 65. That means this value we got, this area is nothing but this is 30%. If our value is fall inside this, and other value change the color, you get to know. Other value is nothing but this side is 70%, this side is 35%, and this side is nothing but 35%. Then our alpha value is nothing but 70%, and our confidence interval is 30%. If after conducting some kind of experiment, if he got our value is coming inside the confidence interval in this stage, then I can, what I can do, I can accept the null hypothesis. If our value is falling inside this or inside this, what I can do, reject the null hypothesis. Reject the null hypothesis is equal to accept the alternative hypothesis. That means in this case I will not do some kind of experiment because it is, as this is the person is committed crime or not. In this case, after conducting the experiment, after collecting the fingerprint DNA or something, if we got that value come inside this 30%, then I can say that this is accept the null hypothesis. That means the person is innocent. And if my value is falling from this 35% or this 35%, that means this 70% area, if my value is false, then I can tell you that the person is not innocent. Till this point, if anyone has any doubt, you can tell me. After that, we just do two or three problems. We can finish. Till this point, if anyone has any doubt, can ask me.
No, sir, continue.
Okay. In this case, what we run like hypothesis testing, confidence interval, and significance value, and all the things we will just run. After that, we will run like point estimator. Point estimate. Point estimate is nothing but, I can tell you the definition. The value of any statistics that estimate the value of a parameter is called as point estimate. That means the value of any statistics that estimate the value of a parameter, that is nothing but called as the point estimator. The point estimator, I can tell you that this is nothing but like mean kind of things. Mean is equally same as the point estimator. I can tell you the definition like there is a formula like confidence interval. Confidence interval, it is nothing but point estimate plus minus marginal error. Your point estimator is nothing but, this is your sample mean. That means point estimator is nothing but, this is your sample mean. That means the value of statistics that estimate the value of a parameter. That means your parameter, there may be a distribution. If that distribution he got value like point estimate, that means your sample mean. In that case, we can derive the confidence interval. In this case, there is also a formula. If confidence interval is nothing but x bar plus minus, this is nothing but the margin of error. This is nothing but margin of error. Then I can tell you that this is nothing but x bar is nothing but confidence interval. If I will tell you one example, you can I will just solve a problem. After that, you can completely understand all the things. Let's say write a question. Let's say I am writing here. There is a question on the verbal section of the CAT exam. There is a CAT exam for MBA. CAT exam is for MBA. Then on the verbal section of CAT exam, the standard deviation is known to be, the standard deviation is known to be, let's say, 100. A sample of 25, a sample of 25 test takers. I'll make you understand everything. Such a mean of 5, 25. Construct a 95% of confidence interval about the mean. That means in this question, what is given to you on the verbal section of a CAT exam, the standard deviation is known to be 100. Then what is the value is given? Here, let's say it's empty color. Insert. Let's say the standard deviation is given as 100, and let's say that you took the sample of 25 test taker. That means 25 examiners. That means 25 students who got the exam, who took the exam. You just collect the data from 25 students, and you will find out the mean of that 25% student, 25%, say 25 students is nothing but that is 525. Let's say in this case you just took the mean of 25 students, and you sorry, this is not 525, this is 520. Your mean is nothing but 520. Your sample is nothing but 25, and your confidence interval is nothing but 0.05%. How you got the confidence? How you got the significance value is 0.05%? As your confidence interval is given 95%, that means significance value is 100 minus confidence interval to 100 minus 95. That is nothing but 0.05%. Okay, then this value is given. That means what the question says in this question, the verbal section of a CAT exam, the standard deviation is known to be 100. That means the standard deviation is 100. If there may be a 100 of students or 1000 of students who got the exam, just you collect the data from the 25 students, and you got the mean of 520. After collecting the data, the marks of the 25 students, you got the mean as 520. Then you just construct the confidence interval by taking the confidence interval of 95%. Just construct the distribution. How can we solve this problem? There is a note in this problem. Note is, if that is nothing but population standard deviation. If population standard deviation is given, we use Z test. In this case, population standard deviation is given. That means we are supposed to test with the Z test. In this case, what we can do, our confidence interval formula is nothing but x bar plus minus z alpha by 2 standard deviation by root n. In this case, our x bar is nothing but 520 plus minus z alpha by 2. Z alpha by 2 means z 0.05 by 2. This is nothing but 100. This is nothing but root over of 25. You can see here, this is nothing but 520 plus minus, I will tell this value, this is nothing but 5 divided by 5. Then how can you construct the z 0.05 by 2? This is nothing but 0.025. How can you calculate the z value of 0.025? In this case, you can go to here. You can go to your Chrome. In that case, what you will do? In that case, you just go to Chrome and search as Z score table. you will get a table from here. Is this visible to everyone? In this table, what you got? You got the value like you got the value from here like 0.025%. That means it is nothing but, in this case you just 0.025, you when you just go to the z table and you will find that in the z table you always search the value from 100 minus 0.25. That means 0.975. This value always is given inside the z table. That means when this value is come, always you have to minus from 100 and you have to go to this z table and search where this 0.975 is given. Let's say I will go to this z score value, and after going to z score value I will search that where is 0.975 value. 0.975 where is my 0.975. Let's say this is nothing but this is not correct table. I will search all. This is z table. This is negative z table. We have to cover. This is positive z table. In this, where we got the 0.975 value. You can see. Sorry. This value 1.96, 1.9 from here and 6 from upper side. You can see this value is nothing but 0.975. Then how can you learn from the z table which value is coming? Your value is nothing but, let's say your value is like 0.025. You have to calculate, but when you will search in the z table, always you have to search for the 100 minus 0.025. This value 0.975. That means you have to search where it's my 0.975. Let's say my 0.975 is here. 975 is here. Then we can see that this is nothing but 1.9. This is nothing but 0.06. That means 1.96. This value I can tell you that this value is nothing but 1.96, and this is nothing but into 20. Then we can say that 520 plus 1.96 into 100, 520. So not 100, this is nothing but 20 minus 1.96 into 20. This value is given. That means their value will be 520 plus what this value will come, and 520 minus what this value will come. This value will become like 559.8. You will calculate and see 480.2. That means if we construct our distribution will fall like this. This is nothing but 0.05% interval. That means this is nothing but 95% confidence interval. This value is nothing but 0.025. And this side value is nothing but 0.025. That means combined this value is 0.05%. If our value is falling inside this, that means our this value is nothing but 480.2. This value is nothing but 59.8. Then if our sample mean is fall inside this value, we can accept the null hypothesis. That means I can say that the which mean I calculated, I got the mean, that is correct. If that value is not inside this value 482 559.8, then I can say that which value I got, that's some mistake, and that value is not correct. This is a problem in the Z test. And when we run in like in the statistics in the Python, and this coding in that coding section, you will got to know each and every depth idea beside this statistics area. I will do one more problem. After that, we can finish the today class. The number two problem. I can write it here. Let's say, and this same question I just change the formula on the verbal section of the CAT exam. A sample of 25 test takers have the mean of 520, having standard deviation of 80. Then the question said that construct a 95% confidence interval about the then in this section what you will do, there is a note from first, there is a note is nothing but in previous question what I told, if population standard deviation, that is nothing but sigma is given, we will do Z test. In this case, if sample standard deviation is given, this the smallest is given, we will do T test. I will show you how can we derive the value from T table, and I can show you that in this case what is given to us. Solution, the first given is that our x bar is nothing but 520, that means our mean is 520, and the sample size is nothing but 25 people, and our standard deviation, in this case, in the previous case we can see the standard deviation is given the population standard deviation. You can see the standard deviation is given, that is nothing but the population standard deviation is this 100, and in this time you can see that the mean of 525, the sample of 25 test takers have the mean of 520, having a standard deviation of 80. That means in this case the 80, the standard deviation 80 is nothing but in the sample standard deviation. That means S is nothing but 80, and after that your significance value is nothing but 0.05%. That's 95% is confidence interval. Significance value is 195, that is nothing but 0.5%. Okay. In this question, what we will do in the what is our formula? Our formula is very simple. Confidence interval is nothing but x bar plus minus t alpha by 2 s by 1. Here what we will do in this problem, we got that x is nothing but 520 plus minus t of alpha by 2, alpha by 0.5 by 2, then s is nothing but 80, and in this case we are not supposed to calculate the root over of n. We are not supposed to root over of we are supposed to do the root over of n, that means the 25. In this case what we will do, that is nothing but 520 plus minus t of 0.025, and this is nothing but 80 by 5. We will calculate this. In this case one more thing is important, the degree of freedom. We have to calculate the degree of freedom, that is nothing but the df, and df is, how can we calculate the df? The formula of df is nothing but n minus 1. When we use that df, I will let you know. In this case df is nothing but 25 minus 1, 24. Okay. In this case, we will just go to the t table and see where our 0.025 value is right. In this case, we will go to this Chrome and search the t table. When already the t table is given to you, the t table, let's say this is our t table. We calculate what the value is 0.9. Always here also, when we calculate the value for 0.025, we will calculate the value. We will see the value of 0.975. Here also we will go to this value. That means in this case, when we will calculate of 0.025, we have to see the value of 0.975. In this case, when we will go to this table, this is nothing but this is 0.995. This value. This is value is 0.975, 0.025. This value will take, and what we get, the degree of freedom is nothing but we get the 24. In this case, in this 24 and this side, which is following like 2.064, this value, our degree of freedom is 24 and our value is t of 975, this value 2.064. This is nothing but 520 plus, this is nothing but 2.064. We just can derive two value, 520 plus 2.064 into 16, 520 minus 2.064 into 16. Then here this value will become like 553.022, and this value will come like 486.978. That means your confidence interval will see if this is your distribution. You can see if this value is like this value is like this is 0.025, this value is nothing but 0.025, and this whole value is nothing but 95% confidence interval. Then this value is nothing but here 486.97. This value is nothing but 553.02. In this value, if we got our value coincide from this, then we can accept our null hypothesis, or we can reject the alternative hypothesis. What we got in this topic, we just did two problems, and we run like hypothesis testing, t-test, z-test, and confidence interval. Just I take some note like where t-test is used and z-test is used. And one more thing is when population standard deviation is given in this note section, I can say that always here one more thing you can find, your standard deviation is also, sorry, your sample size is also always greater than 30, and here your n size is always greater less than equal to 30, less than equal to less than 30. Okay. In this section we just run like hypothesis testing and all the things like confidence interval and all the things like z-test, t-test. We run all the things. If anyone has any doubt, you can ask me. In the tomorrow section, tomorrow when we will conduct, in that section we will run like ANOVA test. We will run like chi-square test. We will run like number 3 permutation and combination. Number 4 is left probability. After reading these 4, our statistics probability will over.